dot products of rectangular coordinate system, rectangular unit vectors and cylindrical unit vectors. So rectangular coordinate system unit vectors and cylindrical coordinate system unit vectors. So this is the heading. Heading is the dot products of rectangular coordinate system unit vectors and cylindrical coordinate system unit vectors. So here I am writing that table here. Actually total there are 3 tables. So first table is this one. We want to calculate dot products, so I am putting dot here. So dot product. Then rectangular coordinate system unit vectors, they are ax cap, so ay cap and az cap. Okay. So anyway, I will write little upwards. So this is we are finding dot product operation. This is rectangular system, ax cap, ay cap, az cap. Now here we want to write cylindrical system, that is zero cap. So a pi cap, az cap, unit vectors, my dear friends. Now actually this is first table and we will be writing the second table and third table. Now I will explain one by one. You keep watching, dear students. So this one is x-axis, okay. This one is y-axis. This one is z-axis. Now first we have to write ax dot arrow. You students know that I will write here. So a bar dot b bar is equal to modulus of a bar, modulus of b bar, then cos of angle between a and b vectors. Okay, like this first one, ax dot arrow, this one, ax dot arrow answer we have to write here. So that is equal to modulus of ax, modulus of arrow, cos of angle between x-axis and rho axis. So if this is now let me write like this. This is the x-axis, so that is why this one is ax cap, right? Now what is this actually? Rho. This is rho. So in this direction a rho cap is there in rho direction. Okay. Now what is already you know that this point already we have studied this one. So you see this. A rho cap, A pi cap, they are perpendicular to each other, AZ cap. Similarly, AX cap, AY cap, AZ cap, they are perpendicular to each other. Okay. Now, this is arrow cap. What is the angle between arrow cap and A pi cap? That is 90 degrees. So 90 degrees means this is like this. This is arrow cap. For this 90 degrees, you have A pi cap. Okay, like because arrow and A pi makes 90 degrees. So here, dear students, this angle is how much actually? This angle is now you students know that this angle is pi horizontal angle. Angle from x-axis to rho value. This is rho axis. Angle between x-axis and rho axis is how much? Pi. So now we want angle between x-axis and rho axis is pi. So this is 1. This is 1. The answer is actually cos pi. So here the answer is cos pi. Now what is second one? Ay dot arrow. So ay dot arrow. So modulus of first vector, then modulus of second vector, then cos of angle between y-axis and rho axis. So this is arrow and this is y-axis. Now that angle is 90 minus pi because angle between x-axis and y-axis is 90. This is pi, so this is 90 minus pi. And this one is 90 minus pi. So this is one cos 90 minus pi means you get first quadrant, that is sin pi you get. So here we have sin pi. Now az dot arrow, you see here az and arrow angle is 90. So that is 0 answer. Now ax dot a pi. So ax dot a pi is equal to modulus of ax modulus of a pi cos of angle between x axis and pi axis. So this is x axis, this is pi axis. So angle between x axis and pi axis, here to here, it is here to here pi. This one is 90. So I will put 90 symbol here, 90 degrees. So angle from here to here is actually 90 plus pi. Here to here 90 and this is pi. So cos 90 plus pi is equal to second quadrant minus sin pi you get. So here you have minus sin pi. Now what is ay dot a pi? So here ay dot a pi is equal to modulus of ay and modulus of a pi, then cos of angle between y axis and pi axis. So here dear students, angle between x and a pi is 90 plus pi, and angle between what do you say, angle between x and y is 90 degrees. Then you subtract 90 degrees from this, then you get angle between pi axis and the y axis. Okay, so otherwise I will do one thing, I will use other ink here so that you can easily understand. So here I will draw once again, draw a now okay, let it be like that. So draw a line parallel to the x axis like this, this one and this one, that is a little bit like this. Okay, this one and this one parallel. So this is which axis? X axis. So that is x axis. Okay, now if that is x axis, then I am removing this one. Already the story of that is over. I am removing that one. Okay, so where is the y axis? Parallel to this you draw. This is y, this one. So this is the y axis. Okay, now what is the angle from I will increase this arrow. What is the angle from x axis to pi axis? Already you have seen that. So angle from x axis to pi axis, here no, angle from x axis to pi axis is 90 plus pi. So angle from x axis to pi axis is this one, 90 plus pi. That is correct. Now what is the angle between x and y? Answer 90 degrees. X axis and y axis 90. So this angle is 90 plus pi. This is 90. Then remaining angle between y and pi is pi angle. So y and pi angle. So this is 1, this is 1. So answer is cos pi. So ultimately you get here cos pi. What is the angle between pi and z here? So angle between pi axis and z axis 90. So answer is 0. Now ax dot az is what? 0, because x and z 90. Ay dot az is what? 90 degrees. So cos 90 is 0. Az dot az is what? 1. So this is the table. Now actually students try to derive all these things. I am telling you, there is no use of that derivation, not at all useful, because every time you can't derive that. So ultimately you have to remember the table. Actually in this way you have to remember 3 tables. So how many tables you have to remember? 3 tables. If you remember these tables, then how to use this table I will explain. But you see what is that, how to use the table, I will explain that. So dear students, now coming to this one here, how to use this table देर आर सो मेनी वेज, बहुत तरीका में वो टेबल को यूज कर सकते हैं आप लोग। ये टेबल अगर फर्स्ट टेबल है, देखिए पहला पहला यूज क्या है, कैसे कैसे यूज कर सकता है इसको, देखिए ध्यान से सुनिए। लिसन, फॉर एग्जांपल you want a unit vector ax cap equation in terms of cylindrical, that is a rho, a pi, az. Then what to do? Ax cap is equal to cos pi into a rho plus minus sin pi into a pi plus 0 into az. So cos pi into, so cos pi into a rho, then cos minus sin pi into a pi means you get minus sin pi a pi plus 0 into az means उतना ही है 0. I will write like that 0 into az because I want to write that in matrix form. So this one, second one, ay equation. If anybody asks what is the ay equation in terms of rho pi z, then sin pi into a rho. So this is sin pi into a rho, then this into this, so cos pi into a pi plus 0 into az. Then what is az cap equation? The answer 0 into a rho, that is 0, then 0 into a pi, that is 0, plus 1 into az, so 1 az. Now you can write this in matrix form also. So how you write that in matrix form? If you want ax, ay, z, so if you want ax, ay, az unit vectors, then you take these terms in the matrix, that is cos pi minus sin pi and 0, and then this is sin pi. So this is cos pi 0, 0, 0, 1. Then here you have no a rho cap, a pi cap, az cap. So you multiply this into this, you get this one, this into this into this, like that. So this matrix gives a relation between unit vectors of cylindrical rectangular system and cylindrical system. Now I want to tell you, my dear students, if you want this, what to do. So here if you want this, what to do. So a rho, a pi, az is equal to, take this matrix, cos pi minus sin pi 0, sin pi, cos pi 0, 0, 1, and inverse is there, don't forget. So inverse ax cap, ay cap, az cap, like this. Now for example, if this is A matrix, then this is A inverse. So you know that A inverse is equal to adjoint A divided by determinant of A. So if you take determinant of this, that is 1 actually, then in this case adjoint becomes transpose for this. Transpose, this is 1 actually. Determinant, no, you can see here, cos pi into cos pi is cos square, minus of minus plus sin square, cos square plus sin square is 1, because that is unit vector matrix. So unit vector matrix magnitude is always unity. Now that is A transpose. So what is A transpose here actually? You take the row and write it column wise. So dear students, now it becomes A rho, A pi, Az in matrix form, that is equal to, so that is nothing but take this table and first row write column wise. So that is cos pi. Why I am telling from table? Because if you know this table, you write this table as it is, you get relation. And if you want these unit vectors in terms of ax, ay, az, then take row and write column wise. So cos pi minus sin pi and 0, then sin pi cos pi and 0, so 0 0 1, and this is nothing but here ax cap and ay cap and az cap. So this is the matrix. Actually, from this one more point I am telling. If you replace unit vectors with components means for example, any vector is there, a bar vector, then a bar vector can have, you can see like this, I am writing here, any vector a bar is there, then a bar can have ax. Okay, I will tell you that. Sorry. For example, if a bar vector is equal to in rectangle system ax, ay, and az, then that is in rectangular system. If you want to convert that into cylindrical system, then that will have a pi, then az. So if anybody asks you, they have given this one, then they want a pi, az. Otherwise, opposite way. They have given a bar vector in cylindrical system, that is a pi, az. They want to convert that into rectangular system, that is ax, ay, az is required. Then what to do? Then answer, if you want, see here, unit vectors, no? In place of unit vectors, I am writing components. So if you want ax, ay, az, then they have given a rho, a pi, az components. Then you write this, you will get automatically direct conversion, cos pi minus sin pi 0. So this is sin pi and cos pi 0 0 0 1. So in place of unit vectors, you replace the component. This is x component, y component, z component of a bar vector. Then you get, if you want these components, then these components are given. You multiply this with this matrix. Similarly, here, if they have given ax, ay, az, then you multiply that with this matrix, that is cos pi, so sin pi 0 minus sin pi and cos pi 0 0 0 1. Then you get here this a rho, a pi, az. Okay. So ultimately, what is the discussion here? The discussion is this table. So how to use that table? You can write unit vectors of this coordinate system in terms of other coordinate system unit vector. So given vector in the rectangular system, then you can convert that to cylindrical. Given a vector in cylindrical system, you can convert that to a rectangular system. So in this way, you can use that table. I will solve one example, no? So that you will understand. So here, you see this one, students. Here, no? Given b bar vector is equal to minus y into x square plus y square ax cap. Okay, plus x divided by x square plus y square ay cap. Then convert b bar into cylindrical system. Then how to do this? Actually, you have to use this one. So in place of a bar, they have given, they want b row, b pi, bz for b bar vector, and then write this. Then they have given bx, by, bz. You have to write this one as it is. Okay. So actually, b bar vector in rectangular system is bx, ax, by, ay, bz, az. Now here bx is equal to, beside ax cap that is there, so this one. And now what is by? So by is equal to, beside ay cap, so x by x square plus y square, so bz is equal to 0. Actually you want in cylindrical, no? That is why you convert them to cylindrical. In cylindrical, y is equal to rho sin pi, and x square plus y square is rho square, and this becomes rho cancel, minus sin pi by rho. Now here x is equal to rho cos pi, and this is rho square, because rho is root of x square plus y square. Rho cancel, you get cos pi divided by rho, this is 0. Now actually what is this b bar vector in the cylindrical system? So b bar vector in cylindrical system is having a rho component, pi component, and z component of b bar vector. Okay, so here you have to use this matrix here, this one. So you want b rho, b pi, bz. So b rho, b pi, bz is equal to, in matrix form, that one is cos pi, sin pi, 0, minus sin pi, and cos pi, 0, 0, 0, 1. And then here you have bx, by, bz. So what is bx here? Minus sin pi divided by rho. What is by? Cos pi divided by rho. So cos pi divided by rho. What is bz? 0. Now you directly convert that. B rho is equal to cos pi into this one, that is minus cos pi sin pi divided by rho, sin pi into this one, so sin pi cos pi divided by rho, 0 into 0, 0. So this becomes 0. Now b pi is equal to this multiplied with this, so minus into minus plus, so sin square pi divided by rho, then this into this cos square pi divided by rho, so sin square plus cos square by 1 by rho you pull out, then that becomes 1. Now bz is equal to 0 into this, 0 into this, 1 into 0, 0. So here now b bar vector in cylindrical system is equal to b rho is how much? 0. Then b pi, so b pi is 1 by rho, so 1 by rho into a pi. Now bz is 0 actually. So this is the example. Now in this way, if you want, you can remember 2 more tables. Actually these tables are used to convert one vector to other vector, and these type of questions are solved in the textbooks, but for exam point of view they are not that much important, dear students. So एग्जाम के लिए ये कन्वर्शंस इतना इम्पोर्टेंट नहीं है, so आप लोग ज़्यादा परेशान होने की जरूरत नहीं है. So for examination they are not that much important, but okay, for the studying purpose you can study, and for exam purpose not that much useful. Okay, you take the examples and convert करो then अच्छा लगता है, but लेकिन ज़्यादा important नहीं है. So if you want you can write two more tables, that is dot products of rectangular unit vectors and spherical unit vectors. So here we are taking dot product of rectangular unit vector ax cap, ay cap, az cap, then ar, a theta, a phi. Then what answers you get here? Sin theta into cos pi. So sin theta into sin pi, then cos theta you get. Then here you get cos theta into cos pi, then you get cos theta into sin pi. This is minus sin theta. So ultimately here you get plus 90 means you get minus sin pi. Here you get cos pi, then a pi dot az is 0. This is the table. And similarly, if you want dot products of cylindrical unit vectors and spherical unit vectors. Okay, so in this case you will be getting here cylindrical system, no? A rho, A pi, A z. Spherical system is AR, A theta, A pi. So rho is equal to R sin theta, so you will get the sin theta here. Here A pi and AR 90 degrees, no? You know that AR perpendicular to A theta perpendicular to A pi. So A pi and AR, no? 90 degrees 0. Then Z is equal to R cos theta, so you get here cos theta. And this one is cos theta, so once again this is 0, this is minus sin theta. So arrow dot A pi, this is 0, A pi dot A pi is 1, so this one is once again 0. So these are the tables, and you can write them in the formula book and you can revise them regularly so that you can easily remember. Okay. So dear students, now let us discuss scalar and vector examples. So what is scalar? Scalar is a quantity having magnitude and sign. Sign is there, plus minus. For example, current is equal to 2 ampere, that is magnitude. Current is equal to 3 ampere, and that is magnitude, minus, that is sign. Here it is plus is there, like that. So plus minus you have. For example, current 2 ampere is like this, means that is plus, opposite means minus, like that. So that is that one. In our subject, what are the examples of the scalars? So scalar examples are Q, capital Q or otherwise small q. Q means charge, so unit is coulomb. T T, capital T or small t doesn't matter, it is time. So second, that is also scalar, it is defined like that. And current is also a scalar, so unit is ampere. And voltage is also scalar. And electric flux symbol is psi symbol, and like this. So we will discuss that electric flux. The unit is also coulomb, because from charge no electric flux is released. So this pi magnetic flux unit is Weber. So you have to now itself you have to remember these names and units. To write the equations you have to remember them. Now what is vector? Vector is a quantity having a magnitude and direction. So it is a quantity having magnitude and direction. Now let us write examples. E bar, electric field intensity, unit is volt per meter. You remember the names now, units and names. Later on we will discuss them, don't worry. Now H bar is a symbol for magnetic field intensity, unit is ampere per meter. Here it is like that, voltage gives electric field, current gives magnetic field, like that. Now D bar is actually it is definition is electric flux by area. So electric flux symbol is psi. So electric flux by area. So unit of electric flux is coulomb. So area means meter square. So coulomb per meter square. So actually per meter square, per meter cube, like that, no, per meter you get densities, actually densities. So electric flux by area, so that is called electric flux density. Name is like that. So that is electric flux density. Similarly, B bar, no, magnetic flux by area. So that means that is magnetic flux density. So magnetic flux density, that is Weber. Weber short name is WB, Weber per meter square. It is also called as Tesla, right? And current by area, that is current density. So ampere per meter square, ampere per meter square. So you have to remember these symbols, names and units now itself. Later on we will be studying them in detail. Now another point what you have to remember is okay. I will take one example. If J bar, example I am taking, if J bar is not a function of time, then J bar is static. Then it is called static actually. So example, you say J bar is equal to 3 into AY ampere per meter square. So it is not a function of time. So that is why it is called as a static. Okay. Otherwise, I will do one thing. I will write the statements, then I will give the examples and I will tell you. For example, if J bar is a function of time, then J bar is called time varying. Third one, if J bar is not a function of x, y, z like rho pi z like r theta pi, it is not a function of x, y, z, rho pi z, r theta pi. Of course, we are talking in a rectangular system. Then J bar is uniform. Uniform means same. Same means constant. So x, y, z are not there means I will explain that even if you change, for example here 3ay, so it is not a function of x, y, z. So at a new location J bar value is 3, that is constant, so that is uniform, like that. So if J bar is a function of x comma y comma z, then J bar is non-uniform. Non-uniform means uniform means same, non-uniform means not same. That means value changes location to location. Here I will give examples now, so that you can give the names. First example, given J bar is equal to 3ax, then what is this? It is not a function of time, so it is called static. And it is not a function of x, y, z, this magnitude is always constant. It is static as well as uniform, both. Example given, it is given in the question J bar is equal to 3x ax, then what is this? It is not a function of time, so it is static. And it is a function of x, no need to have x, y, z all, at least if one variable is there, no distance variable. If time variable is there, that is time varying. If time variable is not there, that is static. If distance variable is not there, then that is uniform. If distance variable is present, then that is non-uniform. So if x value changed, then this j value changes, that means it is non-uniform. So it is non-uniform. Example, given J bar is equal to 3 sin omega t ax, then it is a function of time, so you say time varying, and it is not a function of distance like x, y, z, so it is uniform. Another example, in the question J bar is given like this, 3x sin omega t ax, then it is a function of time, so it is time varying, and it is x is also there, so it is non-uniform, this one. So time varying concept is different, uniform non-uniform concept is different. Now while taking dl bar, double integral ds bar, double integral dv, triple integral dv, Here only distance parameters are there like x, y, z, x, y, z, x, y, z. So whenever you take integrals, our concentration is whether it is a function of distance or not a function of distance. If not a function of distance, then that is uniform. If it is a function of distance, that is non-uniform. So, I will take one example now. You see this one. Note observation, students. First one. Given h bar, what is h bar here? Unit you see, ampere per meter. That is vector. So, given h bar, where it is given in the examination question. So, given h bar is non-uniform, then current I is, you see this, you take single integral of h bar dot dl bar. Actually, dot product gives scalar. Okay, it is scalar. And if you see the unit of this is ampere per meter and this is meter. So meter cancel, you get ampere. So ampere means what? Current. So this is the formula. Second example I will take. Second example. In the note. Okay, in this itself I will write. Next line. Given h bar is uniform, then current is equal to integral h rho dl. I told you if h is uniform like this, for example, it is not a function of distance like this or otherwise like this also, then it will come out of the integral like this, students. 2 dx, 2 is constant, no? 2 integral dx, like that it comes. So it comes out of the integral h bar, that becomes h bar integral dl bar. Now integral dl bar is nothing but L bar. So now the answer is, if h bar is uniform, then current is h bar dot L bar like this. No need to take the integral because that is constant. Then total length vector you will take like that. I will write for you like this. Then h bar dot dl bar, and that gives h bar dot L bar. Here what is important point? If it is uniform, then this h bar comes out of the integral. That is important. So in the total subject, integral is there, and inside that integral, any physical quantity like E bar, H bar, J bar, if they are uniform, they will come out of the integral. No need to do the integral, no need to waste the time. Second example I will take. Given current density J bar, this one, unit is ampere per meter square, is where it is given in the exam question. Is non-uniform, then current is, so you take double integral J bar dot ds bar, then what will happen, students? This dot product gives scalar, current is a scalar, and the unit of this is ampere per meter square and this is meter square, so that meter square you get ampere, ampere means current. Now in this once again, given J bar is uniform. Uniform means like this, maybe like this or maybe like this. Non-uniform means distance parameter is there. So if distance parameter is there, for example, integral x dx, this x you can't get outside. If J bar has x, y, z, you can't get that outside. You have to do the integration. So I am giving you hints now to simplify the formulas. So given आपको hints दे रहा है अभी, given J bar is uniform, then current is simply I is equal to the J bar comes out, so double integral ds bar, so that is nothing but J bar dot double integral ds bar is total surface vector. Already I have told you, you can revise that. So given like this, I will tell you later on rho v, that is volume charge density. So it is coulomb per meter cube, that is volume charge density. Rho v, v means volume, rho is the symbol of charge density, rho v volume charge density. Given rho v is non-uniform, it is non-uniform, then charge symbol is q, is q is equal to rho v dv, because this is scalar, it is not having direction, so scalar into scalar is scalar, and rho v unit is coulomb per meter cube, this is meter cube, so meter cube down you get coulomb, like this. So if rho v is uniform means it is not a function of distance. So for example, rho v is equal to 20 xyz, then xyz is there means you have to put inside integral. For example, if rho v is 20, then that is constant, then you can get outside the integral. So in that case, if rho v is uniform, then charge is equal to rho v comes outside, so triple integral dv, that is nothing but rho v into total volume, like this. What is the conclusion here? What discussion is going on? In any formula like h bar, like j bar, like rho v, if they are functions of distance variables, then they are non-uniform, they must be inside they must have integral, you have to integrate them. If h bar like j bar rho v in the equations, if they are not function of distance, then they can come out, no need to do the integral. So that is the discussion here, dear students. Okay, so students, now let us discuss a few points. First point is grad v is it is a vector. Second point is grad v is perpendicular. Perpendicular means 90 degrees. Normal. Perpendicular to the surface vxyz is equal to constant. Third one, the direction of grad v is in the direction of maximum rate of increase of v, that is scalar v. Actually where v is scalar. So it is in the direction of maximum rate of increase of scalar v. I will explain them by taking one example. Let us take example vxyz is given as y. It is given as y actually. Then if you take grad V, then dou V by dou X AX plus dou V by dou Y AY plus dou V by dou Z AZ. So here grad V is equal to dou V by dou X means dou V by dou X means dou by dou X of V is Y here. Then partial differentiation with X means X is variable, others are constant. Then you get d by dx of 1. So d by dx of 1 means that is constant, that is 0. So like this, 0 into x is 0. So dou v by dou y means you get 1 ay. Dou v by dou z means you get 0. So here grad v is actually 1 into ay. Now I will take this as a y-axis, this as a z-axis, and this as a x-axis here. Okay, I will use this equation. Now I will draw a line parallel to the z-axis. So this is z, then this is x, so this is also x here. That means this is xz surface. This is also called as y is equal to 0 surface, because here y value here is 0. For example, here y is equal to 1, here y is equal to 2, like that. Here 0 is constant, so it is also called as y is equal to constant surface. Now this one is ay cap. This makes 90 degrees with this y is equal to 0 surface. Now you can understand all the points. Here v is y, no direction, so it is a scalar. V is a scalar. And grad v has a direction, so it is a vector. So grad v is a vector. Grad v is perpendicular, that means grad v, that is ay. So ay is perpendicular, that means 90 degrees to the surface. V is equal to constant here, v means y here. So y is equal to constant surface. This ay makes 90 degrees. That is also correct. Now the direction of grad v, that means ay, is in the direction of maximum rate of increase of scalar v. So here scalar v, that means y, increases in this direction. So that is the direction of ay. Now next point I am writing here. Fourth point. The scalar component of grad v in the direction of a cap, so that is some unit vector, a cap unit vector is grad v. I told you, if you want scalar component of any vector in unit vector direction, then you have to take dot product of that vector with unit vector. So here this grad v dot a cap is also called as grad v means directional derivative of scalar v. Then you are taking dot product means in the direction of a cap, or otherwise along a cap you can write. I told you, no? This grad v means this one. Dou v by dou x means derivative in every direction. So that is called directional derivative. So it is also called as rate of change. In some books they write space rate. Space rate means space variables are x, y, z. So rate of change of scalar v. That means rate of change of scalar v means grad v, that is in the direction of a cap. Now I am expanding this one. Grad v dot a cap is equal to like a bar dot b bar formula. So modulus of grad v, modulus of a cap. Let us take angle between them is theta. So now grad v, modulus of a is 1 actually. So it becomes modulus of a is 1, that is unit vector. If theta is 0, then grad v dot a cap gives simply modulus of grad v, cos 0 is 1. So you know that when theta is equal to 0, cos theta is 1, that is the highest value. You multiply this with 1, then that is the highest value. So that is why this modulus of grad v is called as modulus means magnitude. So magnitude, and whenever theta 0, it is the highest value. So you call magnitude of maximum. Grad v is directional derivative. So maximum directional derivative of scalar v. Okay, every time I am writing scalar means here v. So actually these points are discussed in mathematics, but in EM theory not that much important. Okay, type we can study them. Next we will discuss divergence. So the concept is divergence. So shortening is simply dive, it is called divergence dive. It is operated with any vector a bar. So this is the symbol. Now actually here a bar is any vector. So a bar is any vector. You know that dot product gives scalar actually. Now first let us see the physical meaning. If divergence of a bar, actually in the exam question anywhere a bar vector is given, then you find divergence of a at single point, you will be substituting one point. Then your answer is positive, then what is the meaning? That is called divergence. Diverge means going away, दूर जाना है. So from where any physical quantity goes out? From the source. For example, here bulb is there. From this bulb, light will be going away. So if any black object is there, then that light will be received by that. So this bulb is called source of light rays. Any black object which receives the light rays is called as sink of that light rays. काला वाला object है, वो light rays को receive कर लेता है, उसको sink बोल देता है. So जहाँ black object भी नहीं है, जहाँ light भी bulb भी नहीं है, उसको neither source nor sink बोलते रहता है. So divergence means in this case a bar, that means that is some physical quantity a bar is going away from the source. Actually, one source is there that generates A bar, then that A bar goes away from that source. I will take one example. If divergence of A bar is negative, actually in the question A bar vector is given, then you got answer negative, then that is called as convergence. Convergence means coming towards, for example, coming towards the sink. For example, light rays come towards the black object, then they end there. वो लाइट रेस है काला वाला ऑब्जेक्ट के पास आके खत्म हो जाता है, उसको सिंक बोलता है. सिंक मतलब खत्म करने वाला है. So A bar is coming towards the sink. Sink means opposite of source. In any question, if divergence of A bar is equal to 0, then it is called as divergence less. Otherwise, it is also called solenoidal. That means neither source nor sink of A bar is present. कोई नहीं है, सोर्स भी नहीं है, उसका सिंक भी नहीं रहता है. सो पहले मैं एक एग्जांपल लेता हूँ इसका, एंड आप लोगों को समझ में आएगा. I will take example formula of EM theory based on divergence concept. I told you D bar is electric flux density, unit is coulomb per meter square. Then it is a vector. I will take here del bar, the unit is 1 by meter. Then I am taking dot product. Dot product means I will get a scalar. Then multiplication unit is coulomb into 1 coulomb, meter into meter square. So I will get coulomb per meter square, meter cube. I will get meter cube, coulomb per meter cube. Actually, one definition is there. Rho V is nothing but del Q divided by volume. So actually different definitions are there. I will tell later on. You see this definition. Here, this is defined as the total charge by total volume. This is one definition. If charge is there like this, big volume is there, then everywhere charge is there, then total charge is Q, then total volume is V, then volume charge density that is defined as total charge by total volume. If there is very small volume called del V, or otherwise is also called dV, so in that some charge is there called Q, then the definition is rho V is equal to limit del V tends to 0, then charge divided by del V. So this is also one of the definition. It doesn't matter if big volume is there or maybe small volume is there, doesn't matter. So ultimately the formula of this is charge by volume. So charge by volume is the definition of volume charge density. This is coulomb and meter cube. So here rho V is volume charge density. Volume charge density. So it is scalar actually. This is scalar, this is scalar, this is scalar. So scalar and coulomb per meter cube unit, what you get is rho V. So in this way, this is one formula in electromagnetic theory. So this is divergence of D bar is equal to rho v. Here already I told you d bar means d bar is electric flux density. The unit is coulomb per meter square. I told you to remember the name. Then I will tell you the concept later on, don't worry. So now I will take one example here so that you will understand. First, I have taken here some positive charge is there. So plus Q I have taken in this volume. Here I am considering one volume here. First, actually here what is there? Here positive charge is there plus Q. Then I have taken very small volume called del V volume. Then you can define here rho V is equal to total charge divided by del V volume. That volume is very small. So that means here rho V volume charge is there in this small volume. Okay, actually this students, point charge means at single location charge is there. Now actually this volume is very small, but how much small? This volume is just around this point charge. इतना छोटा है ये वॉल्यूम, ये पॉइंट चार्ज को साइज जितना है उतना ही साइज है इसका भी डेल्टा वी, बट मैंने थोड़ा बड़ा कर दिया क्योंकि उतना ही ड्रा करेंगे तो वो दिखता नहीं, इसलिए. Now let us say here some minus charge is there, minus point charge is there. Then here also I am considering one small volume. Then that volume is delta V like this. Here you have rho V is equal to minus Q by delta V. It is called as minus rho V. So now it is, let me draw one line here. Now this is sink actually, negative charge. It is source. Now here I will take one more volume here. Okay, the concept is electric flux density lines. Later on we will discuss that. Electric flux density lines start on the positive charge and go to the negative charge and end here. Let us take that charge is here, end here. खत्म हो जाता है. So that d bar lines goes like this and end there. They are going like this. Because you should understand one simple thing. If there is a charge, then that from that charge some physical quantity is generated and goes away. Then it ends on the negative charge. That is experiment actually. That is experimental statement. Experimentally it is found that electric field lines or otherwise electric flux density lines start from the positive charge and go away and then end on the negative charge, otherwise sink. That is the concept. So now if you consider one more volume here, small volume, here how much charge is there? Zero charge is there. So rho V is equal to 0 here. 0 by some delta V volume. So 0 charge is there. 0 charge means what? Neither source nor sink. That means neither positive charge nor negative charge. Now this is the situation. Now what I am telling you is you take this equation. If I calculate divergence of D at this location, then answer is plus rho V. That is the meaning is at this location plus rho V source is there. From that source D bar goes away, otherwise diverges from that location. Now if you take divergence of D at this location, then answer is minus rho V. Meaning is at this location sink is there. So D bar come towards that sink and ends there. खत्म हो जाता है. Then if I take here divergence of D bar at this location, then answer is 0. Meaning is that inside this volume neither positive charge nor negative charge is there, neither source nor sink is there. So the D bar cannot be generated from this location, cannot be ending at this location. That is correct. This D bar is going, no, that is coming from this source, not from this location. For example, if any D bar, a second line goes and ends here, then you can say at this location D bar is converging, you say, but that is not happening here. It goes and ends here again, like this. So similarly here from this location nothing is generated because no source is there. That is the physical meaning of that one. So now we have to write the formulas. So dear friends, divergence of A bar formulas, derivations are there in the mathematics to get the formulas of divergence of A bar in the three coordinate system. We have derivations. So from those derivations we get the formulas. Now you have to remember those formulas. Okay. So formulas of divergence of vector. Here now formulas. Here A bar is any vector. A bar is any vector. First one. In the examination, it is given that A bar vector has X component and Y component and also Z component, that is a rectangular system. Then divergence of A bar formula is dou AX by dou X, dou AY by dou Y. That means you take X component of A vector, then differentiate that with respect to X. Similarly, you take Y component and differentiate with Y. Then you take Z component, partial differentiate with respect to Z. So dou AZ by dou Z. Now second formula is given A bar vector having rho component, then pi component, then Z component, that means rho pi Z component, then divergence of A bar is equal to 1 by rho into dou by dou rho. You take the rho component and multiply with rho, then partially differentiate with rho, and again 1 by rho is there. This is coming from derivation. Big derivations are there in mathematics. And then 1 by rho, dou A pi by dou pi plus dou AZ by dou Z. Now third formula is given A bar vector is having R component and theta component, then pi component, then it is actually spherical system, then divergence of A bar is equal to 1 by R square dou by dou R square AR plus 1 by here R sin theta, so dou by dou theta, and take A theta, that means theta component, then multiply with the theta, then you have to partially differentiate with this one. Then 1 by R sin theta dou A pi divided by dou pi. So these are the formulas of divergence. You have to remember them. Okay, they are coming from derivations. Derivations are there. Now, Laplacian operator. So this is a Laplacian operator. Okay, and this is the del square V. Anyway, Laplacian operator is del square V actually, del square only. Laplacian operator or otherwise simply Laplacian means del square. Now we have to take a scalar Laplacian formulas. So actually it is del bar dot del bar, and this one is equal to divided as del square. So this one is dot product of dou by dou x ax plus dou by dou y ay plus dou by dou z az. This is dou by dou x ax plus dou by dou y ay dou by dou z az. Now you take ax dot ax now 1. Now that is equal to del square. This is del square only. Del square is equal to dou by dou x of dou by dou x, and ax dot ax is 1, ax dot ay 0, ax dot az 0. So that means every time you get only y term, then only z term, like this. So this is nothing but dou square by dou x square, double differentiation. So that means del square means actually double differentiation, students. Now if you take here any scalar v, then that scalar comes here, then that goes here, 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 like this. But actually it is not that simple. Like this you will not get. This is not the actual form, actual derivation. Derivation is different. But anyway, formula is this one only. But this is not the derivation. So in mathematics, no, del square v has a derivation in rectangle system, cylindrical system, spherical system, in 3 coordinate system. This is not the derivation. This is not correct way. But anyway, formula is correct. So this method won't work for cylindrical and spherical system. And the formulas of del square v in the 3 coordinate system are obtained from the derivations. Now we have to remember those formulas. Now it is double differentiation. Let v is any scalar. Then first formula, given scalar is a function of x, y, z, that is which coordinate system? Rectangular coordinate system. Then del square v is a formula. After derivation you get this one, dou square v by dou x square, dou square v by dou y square, dou square v by dou z square. Now coming to the second coordinate system, given scalar is a function of rho comma pi comma z, that means it is in cylindrical system, then del square v formula is 1 by rho, dou by dou rho, rho into dou v by dou rho. First you take single differentiation, then multiply with rho, then again you take second differentiation, then divide with rho. So that is the formula you get after derivation. You have to remember this. Then 1 by rho square, dou square v by dou pi square, so dou square v by dou z square. Third formula, given scalar is a function of r comma theta comma pi, that means that is spherical system, then del square v formula after derivation you get this 1 by r square, dou by dou r square into dou v by dou r. That means take scalar and partial differentiate with r, then multiply with r square, again partial differentiate, then divide with r square. So here 1 by r square sin theta, dou by dou theta, sin theta, dou v by dou theta. So that means take differentiation of v, partial differentiation of v with theta, then multiply with the sin theta, and then again partial differentiation with the theta, then divide with divide with r square sin theta. So here 1 by sin square theta, dou square v by dou pi square. So these are the formulas of Laplacian operator in the 3 coordinate system. In these formulas, if we replace actually I am writing like this. In these formulas, if you replace V with A bar, then you get formulas of del square A bar in 3 coordinate system. So in above formulas, if we replace V with A bar, then we get formulas of vector Laplacian, that is del square A bar, vector Laplacian del square A bar. Okay. Actually, what are the example formulas of example formulas in electromagnetic theory based on Laplacian operator? Answer is Laplace equation and Poisson equation of static electric field as well as magnetic field. We will discuss that later on. Don't worry about that one. So you have to remember these formulas. Okay. Now let us talk of curl. So actually meaning of curl is rotation, or otherwise it is also called as a closed line. Closed line means circulation. So curl means rotation actually. That is the physical meaning. Now coming to the formulas of curl. First formula, given A bar vector is in rectangular coordinate system like this, rectangular coordinate system like this, then curl of A bar is equal to determinant of first you have to write unit vectors. Determinant Ax cap, Ay cap, Az cap. Then actually it is like determinant of A bar plus B bar type. Then you have to write coefficients of first vector, that is del bar, that is dou by dou x in rectangle system, dou by dou y and dou by dou z. Then you have to, in third row, you have to write the coefficients of in first row unit vectors, and in second row coefficients of del bar. In third row you have to write coefficients of this vector A bar. So these coefficients are x component and then y component and then z component. Actually for curl operation also in mathematics derivations are there. From that derivation you get one formula for del cross A. Then that formula is you expand this determinant, then after expansion whatever you get, that is the formula you get after derivation. So expansion, you know, Ax, then you leave this column and row, then you differentiate this dou by dou y of Az minus of dou by dou z of Ay, then minus of Ay, you leave this one, dou by dou x of this one, minus dou by dou z of this one, plus Az into, leave this one, dou by dou x of Ay minus dou by dou y of Ax. That is the expansion, determinant expansion. So actually in the many textbooks they expand this and give the formula. It is difficult to remember that. So that is why you have to remember the formula in determinant form. That is easy actually. Why in textbook they give in expansion form? Actually for curl operation there is a derivation. After derivation you get that formula. That is why they write that formula directly. But for remembering purpose, याद करने के लिए डिटरमिनेंट फॉर्म आसान होता है. So second formula, given vector A bar is in cylindrical system having rho component, then pi component, then a unit vector, A pi cap, then z component is there, then curl of A bar is, a student don't write this, first listen then you will write. Actually, first whatever you write, that is not correct. You listen. Write similar to that. First, you have unit vectors of this in first row. So, A row cap, A pi cap, A z cap. Then del bar is nothing but dou by dou by dou by. Here, differential length in x direction, differential length in y direction, differential length in z direction. Similarly, here differential length in rho direction, differential length in pi direction, differential length in z direction. Then in third row, you have to write coefficients of A bar vector, that is A rho, A pi, A z. But I am doing some modification. Here actually 1 is there. Nothing means 1 is there. I am writing that 1 as 1 by rho into rho. I am sending this rho into the determinant. Then if you send anything into the determinant, then one of the row or one of the column is multiplied with that. If I send this inside, I am sending into this row, into this column, then it is not there here. Then this row in the denominator row, that is in the denominator, they cancel, so that you get this one. This is the way you remember this one. You expand this one, you get one equation. That equation is same as the equation you get after derivation for del cross A in cylindrical system in mathematics. This is the simple way of remembering. Now that means here rho is multiplied, here rho is multiplied, here 1 by rho is there. By this time you understood how to remember the formula of the spherical system. So here I am writing that one. So third one, given A bar vector in the spherical system AR plus A theta and plus A pi, then del cross A formula. So I am writing here, first you don't write, listen, then you will be writing that. Actually anyway, here place is less, we will write this there, that side. Here we will write. So third one, student. Third one is given A bar vector is in a spherical system having R component, then a theta component, then pi component. So then del cross A bar is equal to, first you see this one, then I will write, don't write now. So students, here first I am taking determinant, then anyway I will remove this also, so that I can write big letters. So here let us take this determinant here. This first row you have to write unit vectors, that is AR cap, A theta cap, A pi cap, students. Then in second row you write dou by dou by dou by. Here in denominator, no, in bottom side you have to write differential lengths. They are actually differential lengths are in R direction, dou R. So this is R d theta, and here differential length is R sin theta into dou pi. So R sin theta into dou pi. Okay. Here in the third row you have to write coefficients of this vector. They are AR and A theta and A pi. So here one is there. What I will do? First I will write here 1 by R into R, then 1 by R sin theta into R sin theta. You send this R here, then here R comes, here R comes, here R comes, here R is went inside. So then you send this R sin theta here, then R sin theta, then R sin theta, then here also R sin theta comes. Now here R into R in denominator R square, so 1 by R square sin theta. Then this R cancel. Similarly R sin theta numerator, R sin theta denominator cancel. So this is the formula, and if you expand this, you get one equation. Same equation you get after doing derivation for del cross A in mathematics. No need to do derivations. In mathematics books you can see them, but how you remember this formula, that is important. So this is the del cross A formula in the spherical coordinate system. Now, what is the example formula of electromagnetic theory based on curl concept? Based on curl concept, I told you to remember a few things. What is that? H bar is magnetic field intensity. So magnetic field intensity, and unit is ampere per meter, and J bar is current density. So current density, unit is ampere per meter square. Now let us take here, dear students, H bar. What is the H bar? Actually unit ampere per meter. And I am taking here del bar. What is the unit of this? 1 by meter. So the product unit is ampere per meter square. And I am taking cross here. You know that the cross operation gives vector. So here vector, this is vector, and the unit is ampere per meter square. So that is J bar, actually J bar. So conclusion is that del cross H operation you take. In the examination question, they have done H bar equation. Then you substitute that H bar equation here. Then you get J bar. The meaning of this is actually, if J bar is there, current density, then that generates H bar. Then H bar will go in circle direction. Circle means rotation. For example, I will be explaining this later on in detail in the subject. Don't worry about that. So actually, if I is equal to 2 ampere current goes, then area is there here, or this area is there. Now this current is crossing this one. So now in this direction, J bar is there, let us say Z direction. Now J bar is equal to this current divided by area into AZ. Now in Z direction, J bar is there. Then around this conductor, H bar is generated. Then that H bar rotates like this. H bar. That means H bar is curling. Curling means rotating around this J bar source. So this J bar is the source that is in Z direction. Then that source generates H bar. Then that H bar actually rotates around this source. Rotates means curls. So this is the explanation for that. Don't worry about this. We will discuss this in subject in detail. We did not enter into the subject. Just we are studying the formula. So next we have to write the formulas of Laplacian operator, dear students. Okay. So dear students, now let us discuss vector differential operator. So this one, vector differential. Vector means direction is there. So differentiation operation, that is why it is called differential operator. Symbol used is del bar. So it is also called del, the symbol del bar. That symbol is called del or nabla in mathematics. It is Greek language. So it is doing differentiation operation like partial differentiation, dou by dou x, dou by dou y, dou by dou z, and directions are there means vector. So it is defined like this. So vector differential operator del bar is defined like this: dou by dou x and ax, dou by dou y, ay, and dou by dou z, az. So unit is 1 by meter. You can see here differential lengths are there. Dx differential length, unit is meter. Differential length. So 1 by meter. So here I want to tell you one simple thing. Actually, normal differentiation d by dx of xy means it is like UV formula. So first you have to differentiate this one. So d by dx of x into y plus then x into dy by dx. So then this is 1, so 1 into y, so x into dy by dx. This is called normal differentiation. Normal means there is no partiality. Partiality मतलब ज़्यादा importance देना है. But here this is dou by dou x. Some students say this del by del x. Anyway you call no problem. But this is you call this del by del x or dou by dou x. The meaning is partial differentiation. You have to show partiality. That means you have to give importance to the one variable, that is x variable. So dou by dou x of xy means give the partiality to the x. That means give so much importance to x. Don't give importance to others, other variables. That means you have to consider them as constants. So dou by dou x of xy means you take x as a variable, others are constants. That is why if you take y as a constant, then it will come out, then only x will be there. If only x is there, then no need to show partiality. You can take normal differentiation like d by dx. Now that is equal to y into, this is 1 d by dx, so this is 1, so y. So now whenever partial differentiation comes now, then directly you can answer. So dou by dou x of xy means simply you put this like this y, then differentiate only x, you get that one. So again and again I will not tell you. So for example like this, dou by dou theta of 2 r square, then sin theta, then cos phi, you got. Then what is the answer to this? Only take theta as a variable. So you differentiate the theta term and don't differentiate others. That is the meaning. So 2r square is like that only, then cos phi is like that only. Simply you differentiate the theta term, and d by d theta of sin theta is actually cos theta. So that is the answer. Very simple. So from now onwards we will get partial differentiations. Okay, you should not confuse. So here, so this is partial differentiation operation. So differential operator with respect to x, then multiplied with unit vector means direction is there, so vector. So partial differentiation operator, it is defined like that. Why it is defined? They wanted to differentiate the variables, that is why. For example, now if I take voltage, unit is volt. Then if I differentiate that now by operating this operator, then the unit of this is 1 by meter. Then a product unit is actually volt per meter. That means volt per meter means that is E bar, because this is vector. Vector of scalar is again vector. So electric field intensity, earlier I have told you that is a vector and unit is volt per meter. You get this one, of course minus sign comes. Now what is happening? If there is a voltage, then if you differentiate that, partial differentiate that in all directions, then it generates electric field. So practically these type of situations exist. That is why they have defined a del operator. So del operator, it is ready to differentiate any physical quantity in all directions. Then automatically some other quantity will be generated. Anyway, this is vector there, so its bar is there. Actually in many books now they don't take bar here. So whether they take bar, whether they don't take bar, it doesn't matter. The equation of this is always this one. Don't confuse. Okay, because in some books now they put bar, but in some books without putting bar, they increase the size of this thick letter like this. Beside that they will write V. So here it is a thick letter, that means that is a vector. And here it is not a thick letter, it is thin letter, that is a scalar. In some books they take like that, so you don't bother about that. Now, actually dear students, already I told you, that charge and time, current, voltage, electric flux, magnetic flux, they are all, I told you, scalars. So what we do, commonly all are called scalar V. Don't think this is voltage. That's simple, no? In our electromagnetic theory, we will say let V is any scalar. Then similarly we have seen let मतलब मान लीजिए E bar, H bar, J bar, D bar, like this. So they are vectors. What we do, let A bar is any vector we will take. So A bar is any vector means it can be E bar, H bar, J bar, D bar, it can be anything. So really in our subject there are scalars and there are vectors. That is why we are discussing them. Now here I am writing let मान लीजिए let V is any scalar, comma A bar is any vector. Now then this del operator is there. This is actually vector, students. Now if you want to operate this with any scalar V, then you will operate like this. So here this is scalar multiplied with multiplied means no dot, no cross, simply side by side you will write. So like this I will explain. Del bar means dou by dou x ax, dou by dou y ay, dou by dou z az. Of V matlab you take V, that V goes here, here, here. So now once again it has direction, so that is why it is a vector. So this is scalar you are operating. Now once again result is a vector. So this operation is named as gradient operation. Gradient means slope. Slope means differentiation. So this has a differentiation here. So that is called gradient operation. So conclusion. If you operate del bar with any scalar, then result is vector. So that operation is called as a gradient operation. You will study this in mathematics. So if you take this del bar operator and operate with any vector called A bar, then this is also vector, this is also vector. Between vectors, two operations are possible. One is dot operation, other one is cross operation. So if you take a dot operation like this, vector dot vector is scalar. So this operation is named as a divergence. Now this is vector and this is vector. You can take cross operation also. Now this gives a vector, so this is named as a curl operation. Now dear students, this is vector, and if you take dot operation then you get scalar. Scalar means no direction, then that is called divergence operation. This is vector and this is vector. If you take cross operation, result is also a vector, that is called as a curl operation. So total 3 operations are there. Now in mathematics subject, del bar dot del bar is equal to del square. That means del is having single differentiation, but del square, I will tell you later on, it has a double differentiation. So del square is called as Laplacian operator. Del square is called Laplacian operator. Now if you take del square, that is scalar actually. That means no direction, dot product, no. So scalar. Unit is 1 by meter square. This is 1 by meter, this is double, no? Double differentiation. So if you operate this with any scalar v, then you can operate that with any vector a bar. Then it is scalar. Scalar into scalar is scalar. So it is called Laplacian operator. If you operate this Laplacian operator to the scalar, then result also scalar. That is why it is called as a scalar Laplacian. So del square v is a scalar. So it is called as scalar Laplacian operator. अगर ज़्यादा पेशेंस नहीं है तो ऑपरेटर बोलने का जरूरत नहीं है, सिंपली इसे Laplacian. Similarly, if you take del square and multiply with vector, multiply मतलब बगल में लिखना है, no dot, no cross like that, then result is a vector. So it is called vector Laplacian. So del square is Laplacian operator. If you operate this with vector, then result is also a vector. So it is a vector. So it is called as vector Laplacian. Laplacian. Okay. So students, total we need formulas for 4 operations. For each operation we need formulas in 3 coordinate system: rectangular, cylindrical and spherical. Actually these formulas come from derivations, you have to remember them. I will be writing them. You see here, gradient is one operation, divergence is second operation, curl is third operation. Laplacian of this one, if you remember formula for one thing, then automatically this you can write. For example, del square v formula is dou square v by dou x square, dou square v by dou y square, dou square v by dou z square. It is double differentiation. Then if you remember this, then no need to remember this formula, because in place of v you replace a bar, here a bar, you get this formula. So that is why you have to remember formulas for gradient, divergence, curl and del square v, that is Laplacian formulas you have to remember. Then automatically if you replace v with a bar, then you get formula of this one. So now you have to see the formulas of each one. First we will see the physical meaning, then formulas, then example formula in electromagnetic theory I will tell you. So now we will be discussing gradient operation. Okay. Now in place of, once again I am telling, in place of v, scalar, you can take charge, you can take electric flux, magnetic flux, like that you can take. Any scalar you have to take, like temperature you can take. So in place of a bar, you can take e bar, h bar, d bar, b bar, j bar, like that vectors you have to take here. Okay. So dear friends, now let us talk of gradient. Gradient, छोटा नाम है, short name is grad. So symbol is this one. Let v is any scalar here. What is the meaning of gradient? I told you, meaning is slope. Now this del bar equation in rectangular system is dou by dou x ax, dou by dou y ay, dou by dou z az, like this. Az. If scalar v taken here, then you have to take v, then that v comes inside and it is differentiated like this. So this is that one. Now what is this? Dou v by dou x means partial differentiation of v in x direction. It is also called as space rate of v with respect to x. Space means spatial variables x, y, z. Otherwise, rate of change of v with respect to x. Like this, partial differentiation with respect to y, partial differentiation of v with respect to z. That means you are differentiating the scalar in every direction. So that is why this is also called as a directional derivative. Derivative means this one in every direction. That is why directional derivative of scalar v. So this is also called as directional derivative of scalar v. Now we have to write the formulas in every coordinate system. So formulas. First one. In the exam question, given scalar v is a function of x, y, z, then that is rectangular coordinate system. Then grad v formula is dou v by dou x ax plus dou v by dou y ay plus dou v by dou z az. That means in the bottom side you have differential length in x direction, differential length in y direction, differential length in z direction. Similarly, given v rho comma pi comma z, that means given in exam question, given v is a function of rho pi z, then that is cylindrical system. Then grad v formula is dou v by differential length in rho direction, then multiply with unit vector. Then dou v by differential length in pi direction is rho d pi. So rho is written here. So rho d pi a pi. Then dou v by dou z az. This one. Differential length in z direction. So third one. Given scalar v is a function of r comma theta comma pi in exam question, then grad v is equal to, so dou v by differential length in r direction is dou r, then dou v by differential length in theta direction is r d theta, so r is written here, then d theta, then dou v by differential length in pi direction is r sin theta d pi, so 1 by r is written here, r sin theta dou v by dou pi a pi. So here differential lengths are there in spherical system, dr, r d theta, r sin theta, d pi. So these are the formulas. Now let us take example formula of electromagnetic theory based on gradient concept. Already I told you, if you take V as a potential, electric potential, the unit is volt, if it is electric potential. Then you take grad here, so gradient of V, then unit of this is 1 by meter. So the product unit is volt per meter. So this gives vector, and vector and volt per meter is electric field intensity in our subject. Actually, what is the discussion here? If there is a electric potential, then you take gradient of that, that means differentiate that in every direction. Then you get electric field intensity. That means electric field intensity is generated. That is the meaning of that. So electric potential can generate electric field intensity. That is the meaning of that. Now, if you see the practicality, for example, if this is a battery of 5 volt, then this is grounded. Here, this is here at this terminal 5 volt is there. Here 0 volt is there. So wherever this positive voltage is there, there positive charge is there in battery side, and here negative charge is there. Positive charge means higher potential, negative charge means lower potential. Now experimentally it is found that electric field direction is from plus to minus. So experimentally it is found that electric field direction is from higher potential to lower potential. But if you use this formula gives electric field direction is from lower potential to higher potential it gives. So how you correct that one? You have to put a minus sign here. So after putting minus sign, again it tells that it gives correct direction to the electric field. The electric field direction is from higher potential to lower potential. So here E is equal to minus grad V. This is formula. Here minus sign indicates that here minus sign indicates E bar, that means electric field intensity. E bar direction is from higher potential to lower potential. So that is the meaning of that. Okay. So if you take minus sign in the formula, then actually electric field direction is from higher potential to lower potential. Then that formula also gives electric field from higher potential to lower potential. Right, dear students. Now actually in exam question, for example like this, given potential V is equal to 2x square yz volts, then find the electric field. That is the question. Then answer E is equal to minus grad V. So E is equal to minus of, here V is a function of x, y, z. So grad V formula is dou V by dou x Ax, dou V by dou y Ay, dou V by dou z Az. That is equal to minus of dou by dou x of this one, 2x square yz. Then dou by dou y of 2x square yz Ay plus dou by dou z of 2x square yz Az. So that is equal to minus of partial differentiation in the x means here you get 2x. So 4x yz Ax cap. Partial differentiation with y means you get d by d of y is 1. So 2x square z Ay plus d by dz of this is 2x square y Az cap. This is the answer. Like this, for example, in exam question, if they give here V is equal to 3 rho z volts, then find E. So rho pi z, pi is not there. Of course, rho z means that is cylindrical system. You have to use this formula. Then similarly in exam question, 6r square sin theta cos phi is given volt, then find E. Then in place of grad V you have to use this formula like that. Okay.